Hi, kids. Yep. Here's another video to increase your capacity to understand capacitance. All right, so this circuit again, so this time I have a combo circuit with some capacitors in there. And again, as always in this class, we're going to talk about the initial state and then the final state, the steady state, after it's been left on for a long, long time. So let's again do just like we did in our last video. We're going to trace how the current's going to go. So ready? So when your circuit is first closed or first completed or connected, remember this is going to act like a closed switch. Why? Because, hey, that's the charge of my capacitor, and here's my other capacitor, so that's my charge on the other capacitor, meaning it has no charge. So let's trace it. Ready? Current's going to come like this. Oh, it's going to go this way. Hey, that's not even part of your circuit. So current's going to go like this. And then look, it's going to get here, and it's going to split. Now, will it split equally? Yeah, it will, because 20 and 20. Now, if it's like 20 and 40, then 40 would get half as much current as this one. But this is 20 and 20, so it's going to split, and then it's going to come together. So if you take a look, initially, what is my circuit? Oh, it's just this part. So let's redraw that circuit, and then we'll analyze it. So, hey, look, this is really what my circuit is at the start, where this is 20 ohms, 10 ohms, and 10 volts. Does everybody follow that? Okay, so look, I combined that, and I got this. So then, okay, hey, I still have a combo circuit, so let's simplify it one more time, and then we'll analyze it. 10 volts. Why? How did I know that? Because 1 over 20 plus 1 over 20 is 2 over 20, which is 1 over 10, and you flip it and you get 10. Okay? But this circuit is going to have a total resistance of, 20 ohms. So if I was to ask you, hey, initially, what's the total resistance of this circuit? You would say 20 ohms, which means there is going to be 0.5 amps flowing here and here, which means there's going to be 5 volts across here and here, and then you could find the power if you needed to, and then if you work your way backwards, well, hey, look, what did I simplify? I simplified a parallel circuit. What is the same in a parallel circuit? Oh, that means voltage, so this is going to be 5 volts, which means, hey, if I go this divided by this, I'm going to get 0.25 amps, 0.25 amps, which I had to get. Why? Because the 0.5 amps splits here, and it split it equally, and so you got that, and that's lovely. And then you could work your way back one more time if you wanted to. Actually, I think we're already there, and so you could say, hey, this is what's going to happen in my initial state. So 0, this would be this stuff, this would be this stuff, this would be this stuff. Initial. Good? Okay. I'm going to erase my initial, and then we'll talk about the steady state. All right, so steady state means the circuit's been left on for a long time, and my capacitors are fully charged. Remember, when your capacitors are fully charged, it's going to act like an open switch. Why? Because charge can't flow into it. It's fully charged. You can't get any more charge that way. So then that means for this one, if you were to trace the current, ready? Here's what's going to happen. Oh, right. Because no more is going to go this way. So that means, oh, right. There's my circuit. So that means I would have 100 ohms in my circuit, which means my current for each of these, using your very nice equation, would be 10 divided by 100 is 0.1 amp, 0.1 amp, 0.1 amp, which then means my voltage is going to be 7 volts. My voltage here would be 2 volts. My voltage here would be 1 volt. This would have 0 amps, and this would have 0 volts because there's no current this way because it's fully charged. This thing stopped the current flowing in that branch. Okay, and then if you were to say, hey, this guy, okay, would have a slope of this, and this would get to 7 volts. And if I wanted to figure out what this would be, I could use this equation. This times this would be 70 microcoulombs, okay? And then if I wanted to do it for this guy, well, it would have to be twice as steep. So I'm gonna go twice as steep as that because the slope is capacitance, but it would only get to 2 volts. Does everybody see why? Okay, which means this value here would be 40 microcoulombs. And then if you wanted to find the energy, just find the area of this piece, 1/2 7 times 70. If you want to find the energy, find the area of this bottom piece, 1/2 2 times 40, and you get your answer. It would be in microjoules, and there you go. So, initial state, steady state. If you understand, it's not that hard. If you try to memorize, good luck. Bye, kids.